Alright, something we're going to be looking at today is taking derivatives of a regular function, f of x over g of x. Now, for taking this derivative, you would normally use the quotient rule. You know, taking the derivative of fx or g of x gives you f prime times g minus f times g prime all over g squared. Never use this. It's horrible. I hate it. Don't bother. Why? Because subtraction, division are not linear, and they get in the way and are stupid and dumb. So instead, let's use something else. Let's try turning this whole thing into a product rule. Alright, so how are we going to go about that? First, let's look at f of x over g of x, which we can rewrite as f of x times g of x to the negative first power. Okay, now we're going to go ahead and let the function h of x be equal to that g of x to the negative first power. So if we were to take the derivative of our new function f of x times h of x, well, this is just a product rule. So we get f prime times h plus f times h prime. Much cleaner to look at, much simpler to work with. So the derivative of f is just f prime of x, easy enough. The derivative of h, well, original h was g of x to the negative first, so h prime is going to be carried down the negative 1 because we have a chain rule, and so it'll be negative g of x to the negative second times g prime of x. Okay, so just to remember, we're going to be doing a product rule of f prime of x times h of x plus f times h prime of x. Let's go ahead and replace our h and h prime. So we get f of x times g to the negative first minus, now we normally be plus, but we take that minus from our negative g of x to the negative second, so we get f of x times g of x to the negative second times g prime. Let's go ahead and rewrite this one more time, bringing down the g primes into the g's to the negative powers into the denominators. We get f prime over g minus f times g prime all over g squared. Last thing we can do, let's make those denominators the same. Let's combine f prime times g of x, minus f times g prime of x all over g of x squared. What you have here is your quotient rule, which you just did through your product rule. So this shows that our quotient rule situations can be turned into product rule situations, and we would definitely prefer that because a product rule is a lot easier. Addition and multiplication are linear functions and so much more applicable, viable, and manipulatable. All right, thank you, and bye-bye.